Hello and welcome to the Car Care channel, and welcome to Toyota's new hybrid system that debuted in the 2022 Toyota Tundra, and now you're going to see it in the 23 Toyota Sequoia. This system is called 1MHV, one motor hybrid vehicle. That's what they called it, and it is completely different from the previous what we are used to, the previous hybrid system in many Toyota and Lexus hybrids. So what is difference? The fundamental difference between the two is this one is called a parallel hybrid system. The previous ones were series parallel, and at some point they were series. This is a very interesting thing because this is the first time that Toyota actually reboots their hybrid system completely and kind of fit it to a different style of cars. In this case, big trucks. In today's video, we're going to take a complete technical tour, and in the end of this video, you will know exactly how this system operates, what each component does, and a lot of the technology that went into this design, which in my opinion is epic. Let's get started. Let's start under the hood. And the first thing is, before we talk about the main conversation, which is the inverter with converter assembly, this is the 3.4 or 3.5 liter V6 twin turbo, and largely unchanged from the non-hybrid model. And this is the cool thing. There is not really much have changed with this engine from the hybrid and the non-hybrid model, and that's the first thing that is unconventional. Usually the hybrid models will have a slightly different engine configuration, maybe the same engine, same size, but it's modified for the hybrid system. This is actually exactly the same, with the exception of two things that we're going to address in this video. So let's talk about the inverter with converter assembly. This is something that we have grown accustomed to in hybrids. This is the brain of the operation. This is what makes all the magic happens, where the voltage comes from, where it goes, and how it's distributed, and everything. So over here, this inverter does two primary functions, and we're going to keep things simple because they're extremely complicated. The first function of this inverter is the inverter part. So this will take the voltage out of the high voltage battery, which we're going to talk about in a little bit, which by the way happens to be 288 volts DC. Is going to take that 288 volts DC, is going to invert it to AC three-phase. And the reason for that is that's what's going to drive the one single electric motor that we're also going to talk about in a little bit. That's the main primary function. The second one is the converter part. This will take your 288 volts DC and is going to convert it to 14 volts to charge the small battery. So if this is going to charge a small 12 volt battery when the car is running, this means this engine does not have an alternator, which it does not. That's the first difference between the hybrid model and the non-hybrid model. Again, this is nothing new or unconventional. When it comes to hybrids, they never had an alternator. They always use the inverter to charge. So this is proven stuff. This is something that really doesn't fail unless you modify it or do things with it. That section where it charges the battery. Now, something that is missing from this inverter, which you notice that it is tiny. I mean, this is very, very small. Even compared to the fourth generation hybrid system, which is very small, this is a tiny unit. And the reason for that is it is missing one function. This does not have the boost function. So if you remember a regular hybrids, you took that 288 volts and we were able, starting with the third generation hybrids, we were able to boost that voltage up to 650 volts to give it kind of a varying level of applying the motors to drive the car. This does not do that. This only uses the 288 volts. Now this inverter does also another function. It regulates where the voltage is going. Are we applying voltage to the motor to drive it? Are we letting the motor charge the battery? Or are we doing nothing? But it also does one more thing. This actually supplies power to the AC compressor, which is electric in this, which is also not an exclusive, something they borrowed from their standard hybrid system. Great idea. You can have the AC compressor on demand. Even when the engine is off, the compressor will be running and you will not have interrupted AC operation. This also controls that. This supplies power to the AC compressor, and that's how it comes to life. But getting more into this, there is one safety feature built in here. When you remove any of these covers, there's actually an interlock circuit that as soon as you remove it for safety, it shuts down the hybrid system to prevent, electric shocks and whatnot. But another thing is, this inverter historically failed because of high temperature. So this guy is coolant cooled. You notice there is an additional bottle here. In addition to these two, which one of them is for the engine, one of them is for the intercooler circuit, this one is for the inverter only. It's a normal, your super long life pink coolant, nothing really, no special coolant here or anything. And in addition to this is gonna cool the inverter using another radiator in the front. It is really hard to see it here, but there's actually a separate radiator just for that, in addition to the two intercooler system radiators and the big radiator for the engine and the condenser. So there is a lot of radiators in the hybrid model here. But there's another thing they added, which is pretty cool. See, the Tundra has a mechanical engine fan. So what happens when the engine shuts off? There's no more airflow across to cool the radiator that cools the inverter. So they added another electric fan dedicated to the inverter radiator, in addition to the other fan, which is used to cool the condenser. So now you have basically three fans. There's two electric fans right here. You can kind of see them from here. There's two electric fans in front. There's the one mechanical one in the back. And that's how this is constructed. Let's talk about the electric motor. And the electric motor actually lives between the transmission, which is right here, and the engine. This is the electric motor. And this is a permanent magnet, three-phase AC 288 volt motor. But there is actually more in this module, that they're calling it, than the motor. There's actually a clutch. So this motor connects to the torque converter on one side, permanently connected to it. But on the other side, from the engine, it actually has a clutch. That clutch is called K0. That clutch engages and disengages. So when this motor is driving the car alone, it actually disengages from the engine and it drives the transmission. When it is regenerating, when you are decelerating, it disengages from the engine, disengages that clutch, and now the force of the road is turning the transmission and in turn turning the motor. When you are driving the transmission with the motor and the engine, this clutch engages, the engine is running, and they're both sending power to the transmission. When the motor is not driving, not doing anything, the clutch will engage, but the motor will free flow and the engine will drive the transmission. Now, when you're charging the battery and driving the car with the engine will be on, the clutch will be engaged, the motor will be turning, not free flowing this time, it's gonna be actually generating, and the engine will be driving the transmission. This is the cool thing about this. This is a pretty clever design because from here on backwards, the transmission is a normal transmission. We'll talk about it in a bit, but this is what makes the hybrid part. You notice it has its own oil pan, separate oil pan, because it uses transmission fluid. It is fed through the transmission. It does not have its own pump alone because there's really nothing going on here. It's just really, it's there for the clutch of the fluid and some cooling. But something else that is cool, this has its own separate valve body that control that clutch, because that clutch is hydraulic. So it has its own hydraulic circuit separate from the valve body of the transmission. That separation, I think, is a good idea because it kind of doesn't cross-contaminate between the two. You only have one clutch here. You don't want too much contamination, the typical contamination of the transmission. So it's a separate deal. Let's talk about the transmission. Now this is a 10-speed transmission, just like the non-hybrid model. And even though this transmission has a different designation, it is actually exactly the same as a non-hybrid model. Same gear ratio, same operation, same cool features, and some of them are, this transmission has 2 oil pumps. One of them is actually chain driven in the front, that's the mechanical one. It basically, here's your input shaft through the torque converter, and then the chain goes to the side, and that's where the pump is. And then it also has an electric pump to keep hydraulic fluid when the engine shuts off and where car is stopped, so you still have hydraulic fluid to drive. Because remember, even though this is a hybrid, you can drive this with the engine off. So you also need hydraulic fluid, kind of primed and ready, clutches engaged, everything ready to go. So that's why this has the electric oil pump. Something about this transmission that this is where things are different. That's why this is a different hybrid system than the norm. This actually still has a torque converter. That torque converter is connected one side to the transmission, one side is connected to the motor or the hybrid module. This is a pretty cool design. I mean, this is a compact unit. If you look at it from this side right here, you can see the hybrid module right here. And then the transmission starts here and goes all the way to the back. And then when you come look at the back of the transmission, it's business as usual. You have the transfer case connected to it, same transfer case, no difference from the non-hybrid model. And everything looks very conventional here. There's not really much difference except for the motor, which we talked about, has a separate valve body, separate oil pan, separate everything, and the transmission has its own thing here. Both of these use Toyota WS fluid, nothing really special fluid or special procedures. Yes, it is a sealed system, but there's not really something unique or special about servicing it. Let's talk about the hybrid battery, which I think is a brilliant design. In the previous Toyota hybrid models, like when you go back to early 2010s, when you got the hybrid model, your trunk space or the rear seat space was severely compromised because of that hybrid battery. You go to the non-hybrid model, it is much bigger and better. Then we go into the late 2010s or right now where we have the modern hybrids. Usually they design them in a way where the hybrid and non-hybrid model will have exactly the same space or very close. In the Tundra, we have the exact same space because this truck was designed from the ground up to be a hybrid model. So in the non-hybrid model, over here, you'll have extra storage underneath the back seats. In the hybrid model, that extra storage is closed off, and that's where the hybrid battery lives. Very smart location for it. This is actually the best place. Many people will wonder, why don't they put the hybrid battery outside the car? I mean, it's a big truck, you can put it under the bed. It is actually a better place for it here. Safe from the elements. You don't have to raise the cost of the truck just to waterproof and weatherproof this. Inside the car also is air conditioned. So now you don't have to have some super complicated cooling system for this battery. Actually, the cooling system for this is something we have grown accustomed to. It is air cooled, and something that I have been shouting all my lungs throughout the life of my channel. Yes, this does have a proper hybrid fan, which lives one on that side and one on this side. Something, of course, you do not want to block, and you want to keep an eye on this filter. Super simple to service and clean and keep clean. And this will extend the life of this battery, which happens to be a 288 volt nickel metal hydride battery. Now, Toyota recently took us to an event where they talked about the technology, and we got a chance to talk to some of the key design people of the Tundra. And the one question I asked them was, why wasn't there a lithium ion option or even lithium ion flat out? Here's the answer we got, and it does make sense. Nickel metal hydride batteries are proven. That's number one. The technology have come so far that they are really proven. They have a long track history with Toyota of reliability. Plus, they perform better in lower temperatures. And for this use, for this truck, this battery actually outperforms the lithium ion. So it was an obvious choice. And another thing is, if you put a lithium ion battery here, the price of the truck, which is already high, will go even higher because lithium ion batteries are more expensive. So there is a nickel metal hydride battery here. It is air cooled, it's 288 volt. Brilliant design and brilliant location. As long as you keep these fans and the cooling vents and the filter clean, you should not have issues prematurely with this battery. And earlier when we looked at under the hood where the inverter was, in the non-hybrid model, that's where the 12 volt battery is. In the hybrid model, the 12 volt battery sits underneath this door right here. Pretty easy to access. Actually, it's a great location. It's not buried somewhere else. You just pull the seat back, pull this cover, it's right there. And something else about this hybrid battery that perhaps you should know about. The way this hybrid battery kind of operates and is wired and designed is exactly the same as other Toyota hybrids. You still have main relays that first come on, check the resistance of the wire, make sure we don't have a short or a insulation fault, shut off, then turn on again. So when you start this Tundra, you will still hear that familiar clicking from the system main relays. There's one for the positive side, one for the negative side, and they also live with the battery. Business as usual. This would be a very, very familiar battery to anybody that has worked or seen regular Toyota hybrid batteries, and this is a welcome thing because even though this hybrid system is completely different and all new, people still are afraid of batteries. Folks, there is nothing exclusive about this battery or completely different and all new design. This is the same battery, same design, same construction, and equally the same reliability expectations as other Toyota hybrids, and this is good. If it was not broken, there was no need to change it. That's why they didn't. Let's talk about the operation of this hybrid system because it is completely different from all the other Toyota hybrids that you are potentially used to, heard about, learned about, and everything. The first thing is the initial start. When you start the car, it is very similar to Toyota hybrids. The first thing that will happen is the main relays in the battery will energize, check the installation of the high voltage cables, and then they will power on. Once they power on, the system is alive, the inverter is alive, everything is working, and the 12 volt battery no longer does a thing. So there is one fundamental difference about how this and regular hybrids drive. Let's talk about it. So in regular hybrids, the hybrid system is kind of takes over. It only uses the engine when it needs to, either charge the battery, warm it up, or you are demanding more power. In this, however, it doesn't do that. The first mode of operation is the start off. As soon as you take off, the hybrid system will assist, and then as soon as the truck takes off, it actually disengages. Now the engine is driving. And then if you all of a sudden need high load condition, like you smash the throttle, for example, you're towing and you need that extra push, the hybrid system then engages. That's the only two times actually the hybrid system will engage. So majority of the time in normal driving, you actually be using the engine. And some people will say, wait a second, that doesn't make sense. Well, actually it does. See, when you have a giant behemoth like the Tundra, it's basically a giant block going down the road, highly unaerodynamic and extremely heavy, and it has this massive air brake in the front. That is the giant grille. You have to optimize efficiency to work its best, not to be counterproductive. Because if you all of a sudden discharge that entire battery just to get this thing going, it's just not going to work very well. Most cars consume the largest amount of fuel when that initial takeoff, because it takes the most amount of load and energy to move an object from stationary to moving. Once it is moving, you're not consuming as much energy. That's fact number one. Number two, when you want to take this enormous behemoth faster, you're going to put maximum load on the drivetrain. So that's when the hybrid system comes in to assist. So you're not solely relying on the gasoline engine. Therefore, hopefully, better gas mileage. We'll talk about the gas mileage thing in a little bit. But then there is more operations. So we said on start off, it's going to rely on the hybrid system. When under heavy load, it's going to rely on the hybrid system. But there's more modes to this hybrid system. When you decelerate, it's actually going to disengage that clutch, the K0 that we talked about, and it's going to use the electric motor, which is connected to the transmission, to charge the battery. Immediately, it's going to do that, which is pretty cool. But let's say you're driving in normal operations. Engine is driving the car, hybrid system is on vacation. Well, what if the battery is low? What if the state of charge is low? It's actually going to use the engine power to drive that motor to charge the battery. And it's going to do that also in regenerative braking, when you brake or when you decelerate. But it's not going to do it as the rate of conventional hybrids, because you have some limitations here. You cannot, there's one motor, you cannot achieve the levels of regenerative braking that you would with regular hybrids, where they have two motors and they are in a different configuration. Now, this truck also has one unique feature. We said when you take off, it's going to use the hybrid system. But if you take off lightly, very lightly, and you don't exceed 25 miles an hour, it can actually sustain hybrid operation until the battery gets critically low, then the engine kicks on and off we go. That is one thing, and the other thing is, it also utilizes a hybrid system for start-stop technology. So most modern cars, and people don't like this feature, I'm with you, I agree, when the engine shuts off at a traffic light. In hybrids, that is the norm. We're used to that. They always do that. Regardless of stop, you just stop, put it in park, the engine is off. Here, that also happens. However, there is a few concerns. See, in regular hybrids, you have two motors that can charge the battery rapidly. Here, you only have one. And then in order to engage that one, it takes some power. So the levels of charge are higher than usual. They cannot get as low as they do in normal hybrids. So what happens when you have a start-stop event? Let's say you came to a traffic light, you were just accelerating very hard, the battery state of charge is very low, and you don't have enough reserve in the battery to actually start the engine. Well, they thought of this one. Normally, most people will say, well, let's just keep the engine running because we need to charge the battery. They will actually not do such thing, because that would be kind of harmful emissions and kind of counterproductive to the whole idea. See, this engine lost the alternator. It lost its belt-driven compressor, but it did not lose its starter. And this is the first hybrid Toyota model to have an actual starter on the engine, for very good reasons. We're going to talk about some of the reasons in a bit. But the other thing is, if the hybrid system, for whatever reason, is unable to start the engine because of the low charge of the battery, that starter will actually start the engine. Very cool safety. So even if the battery charge is low and you come to a stop at a traffic light, it's going to kill the engine regardless. Because if we can't start the engine with the hybrid system, we're just going to use a good old starter. Very, very brilliant here. This is a really cool thing. Let's talk about some unique features of this hybrid system, which there are a few that are really interesting. The first one is, we talked about this engine having a starter in addition to the electric motor being able to start it. So this starter actually has two more things about it, other than being a backup for the hybrid system in case it cannot start the engine. So when the temperature is below 5 degrees Fahrenheit, when you first start this truck, it will actually, even if the hybrid battery can start the engine, it'll bypass it, it'll use the regular starter for very good reason. See, in regular hybrids, we do not have a starter. People, including myself, I own a hybrid, a regular hybrid. People complain about rattles or kind of an abrupt start and the engine kind of runs a little rough. And that's because in very cold temperature, You actually do not want to abruptly start the engine like that because oil is thick, there's no oil flow, VVTi system is disengaged and it doesn't have oil flow. It's just not the best thing for an engine to start abruptly at full speed when it's completely cold like that. So in this case, it's going to use the regular starter, which cracks the engine at very, very low RPMs, unlike the very powerful motor. The other case where the starter will actually start the engine, and this is something you can actually duplicate yourself to see how that starter sounds. It will start the engine every time you open the fuel door and close it when the engine is up at operating temperature. Now, the textbook says that that is due to kind of a maintenance to the starter so it wouldn't seize, and that makes absolute sense. But I think it's just logically and kind of knowing powertrains and everything, there is potentially another reason for that. And because it's very specific, only when you open the fuel door and only when the engine is at operating temperature. Vapor lock. See, if you have a vapor lock and you crank this engine at full power of the electric motor, which does not take compromise, that electric motor will crank this big V6 at idle speed, at probably 800 to 1,000 RPM in a millisecond. If you have vapor lock and you abruptly jam the engine like that, you might cause damage, not only to the hybrid motor, but to the engine itself. So they instead use the starter, which not as abruptly starts the engine at normal speed. Pretty cool, and you can actually duplicate this, just have the engine fully warmed up, pop your fuel door open, close it, go start your hybrid system. The engine will start with a starter every time. That is designed that way. The other thing about this hybrid system, because it is not really a full hybrid system. And this is something interesting because when you look around this truck, this is the TRD Pro model, you will not see a single badge around it that says hybrid. You will not see it inside. You will not see it anywhere other than marketing materials. And the reason for that is obvious. This is not a full hybrid, not like the regular hybrids, because this is more of an assist. It does help a little bit with gas mileage. Talk about that in a little bit. But it helps with giving this engine more power and letting it run more efficiently. And the reason many people will ask, why didn't they just go with the regular hybrid system? Put it here, works great, ECVT and whatnot. See, the biggest problem with the hybrid system is towing. It does not do too well with high payloads and extended towing. It just cannot cope with it. That is one of its downfalls. The motors heat up, the inverter can't keep up anymore, and it's just too much. You need a proper transmission for that. And that's why they went with this. And it works flawlessly. The one thing about parallel systems that is usually a problem, we've seen that in Hyundai with their parallel system. It is clunky, slow, and just not smooth operating. This, however, completely smooth. You will not even feel the transitions, and that is a huge deal because you have the best of both worlds. You have a proper transmission for towing, you have a big engine that has a lot of power, and now you have the boost of the hybrid system to give you a little bit more efficiency and, more importantly, more power without having a bigger engine that now doesn't pass emissions and all that. And because of that, you do not have an EV button like normal hybrids. You press it, you're forcing EV mode on. This doesn't have that because it is not really designed for that. This is more of a boost to the engine and the regular drivetrain, not really designed to kind of behave like a normal hybrid. And some people will like that because typically truck owners, they don't like hybrids very much, at least from experience. They like their big engine and big, loud, shouty truck, which this is that. Now, there are a thing or two that are not actually very good about this new hybrid system. Truth have to be said. We drove this truck for a week. Toyota gave us the truck to test it out, check it out, and do this video and the TRD Pro trim review, which you will see come up in the channel soon. The first thing is, because of all this additional stuff, the prices are very high. All these hybrid components, they had a lot of cost. So the truck is already expensive and the prices are rapidly rising because of this hybrid system. That's the first thing, and perhaps that's to be expected. But the other thing that is kind of a heads up, or by the way, for your information, the gas mileage in this is not good. It has to be said. Because most people are used to buying the non-hybrid model of a Toyota model, and it gets decent, okay, gas mileage, and then we go to the hybrid model, there's quite a jump. Well, there's not quite a jump here. And in the real world, you're not really gonna get that gas mileage that you're accustomed to with hybrids. Not like the Sienna, my good friends. The Sienna used to get horrendous gas mileage when it had a V6. When you went to the hybrid, it got just unbelievable gas mileage. Here, that is not the case. So again, I will say this, I might have said it in a previous video. If you want to buy a ginormous truck like this one, that is basically a giant block going down the road, big air brake, do not expect good gas mileage. The end. This gets better gas mileage than the previous one, of the V8, which had absolutely no effort to get any better gas mileage, but it's not by a lot. And that's how it is with these big trucks. So the moral of the story is, you buy this hybrid system because it gives you more power, kind of a more refined powertrain, not really for gas mileage. That's the God honest truth, folks. This is done really well, but not for gas mileage. I see it more for more power, more robust towing than it is for gas mileage. There you have it, folks. This is the Toyota new hybrid system. It does have a thing or two, mainly the gas mileage thing is not ideal, but for the function of this truck, it actually works really, really well. Very well engineered, very well made, and this is just the kind of the intro to the newest hybrid innovations that Toyota comes up with. We already have announcements of the 2023 Prius. We have the kind of the super hybrid model in the Crown that makes a lot more power than usual, and a lot more to come. Folks, I hope this video is helpful and informative. I hope you learned something new. If you like it, consider giving it a thumbs up. If you're not a subscriber, consider subscribing to the channel. Check out some of my other videos. And until the next video, folks, may the Lord bless you and keep you, and you have yourself a wonderful day.